All right, the last question on this quiz is about the 4 conditions to determine if we're in the binomial setting. And those conditions require us to have a quantitative variable. We do, so we are counting the number of past quizzes out of 4. So why is quantitative? It's the number of past quizzes out of 4. And it's discrete because I'm counting them. So we've got the quantitative, we've got the discrete. For the binomial setting, I need a fixed number of trials. Now we are applying 4 quizzes to each student. And so the number of quizzes is 4. And then we're going to have independence. We need to test for that. We need to test if there is 2 outcomes. I should start there. Yeah, so 2 outcomes would either be you pass the quiz or you fail. And so passing is deemed the success. And is the probability of success the same? Is it constant with each trial? Now, I'm just listing out the conditions. We need a fixed number of trials. We need to test whether we have independence. We need to have 2 outcomes possible, a success and a failure, and then the probability of whatever we're calling success needs to stay constant each time we conduct the trial. So for the quizzes, there are 4 quizzes. It's kind of like I'm assessing a student's understanding. We're keeping that to 4, and 4 quizzes is way less than the total, in fact 5%, of the total number of assignments or assessments that are possible to give to a student. And so even though I'm taking a test, I'm not going to put it back in, and we're testing without replacement, blah, blah, blah. We're keeping that sample size relatively small compared to what is out there or possible. There are 2 outcomes. They either pass the quiz or they fail. Does the probability of success passing the quiz, each trial, each one of the 4 quizzes remain the same? I'm going to go back to the very first page. So I see for a student, the probability that they pass the first quiz is 0.7. Now, it is not the same if they pass the first quiz, the likelihood that they pass the second quiz is still 0.7. But what if they didn't pass the first quiz? The likelihood that they pass the second is now 0.6. So it's conditional on whether or not they pass the first quiz. The probability of you passing the second one depends on the passing the first one. If you pass the first quiz, it's 0.7. If you didn't pass the first quiz, it's 0.6. The probability of success is changing depending on the previous trials. So we don't have that consistency on probability for success. I've lost where I was writing this down. So this very last condition, we fail. So we are dependent on the previous trials. So it does not satisfy the binomial setting.